Hi to everyone and welcome to this Trotec Laser webinar. Okay, right now I'd like to introduce today's presenter, David Stevens. David is renowned in the industry for his teaching abilities and helping customers improve their laser processing techniques. Now, for nearly 2 decades, David held multiple roles at Universal Laser, including Applications Lab Manager, where he built, designed, and produced a catalog of laser parameters and standardized settings, and Senior Global Technology Specialist. He recently joined Trotec Laser as the Industrial Applications Manager and heads the West Coast Applications and Inspiration Lab. So, David, welcome to today's event. And with that, I'm going to pass things along to you to get us started. So, David, go right ahead.
Well, hello, everyone. My name is David Stevens. I'm the Industrial Applications Manager for Trotec Laser. And today, we're going to cover laser marking methods, what they are, and how to choose the right one for your application. This seminar is set up with QR codes, so please keep your smartphone or tablet near during this presentation for new processes, products, materials, and techniques that may go beyond this seminar. We are a very social company, so if you would like to keep up with current capabilities, techniques, materials, products, please follow us on YouTube, Facebook, or Twitter. Each QR code here will take you to each location. The main objectives for this seminar include a detailed explanation of different methods used to laser mark plastics and metals in an industrial environment. Examples of applications for which each marking method is best suited. Instruction on how to determine the best method for your application. And an overview of technologies available and practical guidance on how to leverage them to achieve a specific result. What is a laser? A laser beam is light which can also transmit energy in the form of heat. The name laser is an acronym for light amplification by stimulated emission of radiation. Lasers have been around since the 1950s and can be traced back to Einstein's theory of light emission in 1916. Different wavelengths of light can produce different types of lasers and produce different effects. The most common industry lasers are CO2 and fiber lasers. Laser technology is an extremely flexible process that can be applied to a broad variety of businesses. Laser systems can cut, mark, and engrave literally thousands of distinctive materials in a wide variety of shapes and sizes. Laser system components consist of a work surface and motion system, a laser light source, integrated control software, lenses, also known as optics, and accessories. Laser designs. There's two popular types of laser systems, a flatbed system and a galvanometer, also known as a galvo laser. Flatbed systems are similar to a desktop printer, where a galvo system typically is used in high volume applications. The difference between a flatbed and a galvo systems are shown here. A flatbed delivery system allows for a large working area, much larger than a galvo. It has less focal tolerance than a galvo. Motion system is very robust and must be robust in order to maintain consistency across the field. It can be set up in multiple configurations with many accessories and upgrades, where a galvanometer system or a galvo system has a much smaller working area. Common ranges are 2.7 inches by 2.7, up to as large as just over 12 inches. The difference is mirrors deliver the beam to the working area, and this is the only mechanical movement are these mirrors. On average, a galvo laser is 10 times faster than a flatbed system, though the field size is much smaller. Besides the type of motion system, the two lasers that are most commonly used in this industry are CO2 and fiber laser. The CO2 lasers offers the broadest range of materials that can be engraved, cut, or marked, materials that are typically organic or plastics. The beam is generated by stimulating a mixture of gases. This laser is in the 10,600 nanometer wavelength, commonly known as 10.6 micrometers. There are three ways to generate it currently known, and those are generated by either a glass laser, a metal laser, or a ceramic laser. Where the fiber laser has a limited range of materials that it can be engraved, cut, or marked. Materials are typically inorganic. Most common are metal, as well as some plastics. The beam on a fiber laser is generated by an optical fiber doped with a rare earth element. These lasers are 1064 nanometer in wavelength, commonly known as 1.06 micrometer. Fiber lasers allow to directly engrave or mark metals without any need for chemicals. In general, a CO2 laser covers between 80 and 85% of most of your common materials, where the fiber laser covers about 15%, the remaining 15%. So between these two laser sources, most materials have the ability to be laser processed. This seminar will focus on the fiber laser and the Galvo system motion system for marking. Fiber lasers have been developed to replace the YAG technology. YAG technology did not last as long and it was harder to control. So fiber lasers came out and became available around the year 2000. They require the least amount of maintenance, they're air cooled, and have the lowest energy consumption. Average marking wattage is between 10 and 100 watts. Systems typically can run over 100,000 plus hours source lifetime. They have the best beam quality, and they're available as pulsed or continuous wave lasers. Focusing on the fiber laser, as well as the Galvo systems, the materials that can typically be processed are mainly metals and some plastics. Metals have the ability to engrave, anneal, to change the color, and also have the ability to remove the coating with a fiber laser, where plastics also will produce some engraving, color change, foaming, and coating removal. Here's a list or a chart and possibilities and ability of each of some of the more common materials laser processing with a Galvo fiber or just a fiber laser. So what are the fiber laser marking methods? We're going to cover each one of the different methods to showcase what they are, how they would work, and when you would use them. Fiber laser marking process consists of laser engraving, which is the process of vaporizing some of that base material, producing a cone shape indentation, a slight subsurface engraving, if you will. Laser marking is producing a contrast on the surface of the material, producing little, if not any, or no depth. Coating removal is using the fiber laser to remove the coating or layer from the surface of those materials. There's also a process called laser annealing. This is where the surface is actually heated by the heat of the laser to produce a contrast mark with no depth at all. Laser coloring, similar to annealing, is utilizing the same heat of the laser to produce colors. And then lastly, we have laser foaming. Foaming is caused by the high heat of the laser with a color change, typically on plastic, to produce a raised effect. So how do you determine which marking method to use? We're going to go through each one of these marking methods, starting with engraving. Engraving is probably the most common, can be done on most of your metals with the fiber lasers. All metal types will directly engrave as well as coated metals. The laser or fiber laser will actually melt or evaporate the metal surface, producing a subsurface engrave into that surface. It requires a high level of energy at a low frequency for depth. Polishing is also possible, producing a bright mark with low energy running high frequency on a second pass. Here are some examples of metal engraving examples. Typically a lot of tool marking, subsurface marking, marks where you need a very permanent high contrast mark that cannot be susceptible to damage of external sources such as shearing, such as UV, and where that part needs to be very durable over a long period of time. If you would like to watch a video of the metal engraving process, please scan this QR code with your mobile device to watch a short metal engraving process video. If you do not have time to do this now, you can download this seminar at a later date and scan these QR codes as we go through this seminar and watch these videos at a later time. The next is coating removal. Coating removal is the process of removing the coating from the surface of the material. Fiber laser heat removes that top layer of that material. Coatings like anodization, electroplating, powder coating, enamel coatings, galvanization, bluing, etc. Coating layer is removed with the laser heat. This produces a high contrast marking at an extremely high rate of speed. Here's some examples of fiber laser marked coating removal, contrast marks, ranging from different colors to anodization to powder coating, and examples to where you would see that contrast when marked with the fiber laser. If you'd like to see a video, please scan this QR code with your mobile device and watch a short video of the process of engraving coated metal with a fiber laser on a Galvo laser system. The next is color changing plastic. Laser marking on plastic produced a contrast on the surface, producing little to no depth. The color change is achieved by the laser removing pigment only and drawing out the contrast, producing no depth at all. The result depends heavily on the composition of the plastic. Not all plastics will process this way. Common plastics that typically work including black acrylic, black ABS, and white ABS, as well as some others. However, testing may be required. Special compensations of plastics are available for good marking results, which means you can actually inject certain components into the plastic if you can control the injection molding or the molding process of the plastic to make it suitable for fiber lasers. Where some materials work naturally, others require this process. However, when laser engraved, the surface is not damaged whatsoever during the marking, producing a high contrast mark that cannot be removed. Here are some examples of the color changed onto plastics. Your keyboard directly in front of your computer most likely has been used with a fiber laser to mark its key letters, as well as many other solutions and common everyday household objects that you may see every day are marked with fiber lasers to produce this color change, as you can see on the example shown here. If you would like to see a color change in action on both white ABS and black ABS, please scan this QR code with your mobile device to watch a short plastic contrast marking video. We can also do a foaming effect in addition to a color change on some plastics. Laser foaming uses high heat with a color change to produce a raise effect. Fiber laser heat removes pigment from the plastic to create contrast. The heat also creates air bubbles on some materials that produce a slightly raised mark. The result depends heavily on the composition of the plastic. Again, not all plastics will process this way, and testing is required. The most common plastic that does typically work is black Delrin. Here are some examples of some foaming, contrast-colored marks. If you would like to see the color change foaming in action, please scan this QR code with your mobile device and watch a short video on the process of contrast foaming. Deep engraving into materials, some materials is also possible. Laser engraving and producing depth vaporizes some of the base of the material, producing a cone-shaped indentation. Well, when increased power is added, as well as additional time is added, depth can be achieved. Laser radiation causes the material to melt or evaporate, causing depressions into the material. Typically, most commonly, this is done with metals and some ceramics. It produces an extremely durable, high contrast, high quality mark. However, high levels of energy are required for this process, in addition to multiple passes, and it is a very time-consuming process. Here are some examples of engraving with depth into the surface of metals. This process, though it takes longer, is ideal for creating castings or molds, or processes where shearing or longevity of the actual mark needs to be into the surface of that material. Now we're going to jump to annealing. Annealing is an interesting process. Laser annealing is where the surface is heating to produce a contrast mark into metals with no depth. Marking by annealing involves heating the surface of the metal in order to create an oxide layer. This oxide layer produces a legible black marking. This works well with stainless steel, titanium, and some other metals, but not all. A local increase in temperature to just below the melting point of the material is required in order to achieve an annealing process. The oxide layer is created just below the material surface. However, that surface is not damaged. It produces an extremely high contrast between the marking and the material. Fiber annealing works on metals with high carbon content. The process requires the beam to be slightly defocused, producing a slightly wider beam in order to produce more heat. This process is slower. You must allow the time for the carbon to rise to the oxide layer. This is typically ideal for medical and culinary type metals. Here are some examples of some annealed metals. Typically, it gives you a very polished surface mark with no depth. It is also ideal when bacteria is involved, such as the medical industry, because when there's no surface actual removement and the metal is still polished on the surface, it gives that clean surface and the inability for bacteria to typically grow. If you would like to see an annealing process done, please scan this QR code with your mobile device and watch a short video on the annealing process utilizing a fiber laser. Metal color change. Metal color changes uses the process of annealing, which is where the surface is heated to produce a contrast mark with no depth, as we just covered. However, the color process works on the same metals with high carbon content, the same process as annealing. The metal is heated to create that oxide layer beneath the surface. But when you play with different heat variances and defocus the beam and apply different variations of heat to the surface of some metals, this process will actually produce color. It is a slower process and it's highly complex. And it can also be difficult to achieve some colors, but it is outstanding in the way that it can do this. You must allow time for the carbon to rise to that oxide layer to get this certain effect, and you adjust the power, the speed, frequency, and pulse duration, as well as the focus to achieve each individual color. We have calibrated many of these colors on some materials, but this is a complex process to do. Here are a few examples of color engraved into a stainless steel. If you would like to see an annealing color change video onto stainless steel, please scan this QR code with your mobile device to watch a short metal color change process video. In addition to a standard fiber laser, there's also a MOPA laser. This is a laser that is slightly different than a fiber laser. It's called a MOPA laser because it's a master oscillator power amp. It has a master oscillator power amplifier. It's a new generation of fiber lasers that give you more control. It gives you adjustable pulse duration and a higher peak power. It also gives the combination of two characteristics of a standard lasers, which is the classic fiber lasers, which produce long pulses, as well as the doped pump solid state laser, which is DPS lasers, which produce short lasers. A MOPA laser produces or combines both of these capabilities to give you the best flexibility and application possibilities. A MOPA laser will actually produce black marking on anodized aluminum, where a standard fiber laser will not do that. It also has plastic marking advantages, producing short pulses that produce less energy, but high power, less heating and burning onto some materials. It produces a broad range of parameters, including pulse shapes and duration. It's got faster marking capabilities, frequency up to 1000 kilohertz. It produces brighter markings, faster annealing processes, and less corrosions of steel when annealing. It also gives the ability to give reproducible colors onto metals. Here is the difference between a standard fiber laser and a MOPA laser, which is really the only two types of systems that we offer. Where engraving onto certain metals, the fiber laser is actually superior than the MOPA laser. It has got more power and it gives you a slight advantage. Marking on coated metals, such as anodized aluminum, the MOPA laser gives additional capabilities, such as the ability to mark dark onto that anodization, where a standard fiber laser cannot do this. Deep engraving of materials is pretty equal when it comes to a standard fiber laser versus a MOPA fiber laser. Now, annealing onto steel and titanium, a fiber laser does okay. However, the MOPA laser gives you far more ability and control when it comes to color and operation onto that process. Black marking of anodization cannot be done at all with a fiber laser, where with the control of the MOPA laser, this can be done. On plastics, the fiber versus MOPA. Marking on plastics produce a better result. We get a better quality, more contrast. Certain colors of plastic are going to give you a brighter response. It's a higher speed marking onto plastics as well. So why laser marking? Laser marking with a laser is superior over most other means of marking, such as mechanical engraving, stamping, printing, inkjet, or etching, because it is usually faster, higher quality. It typically gives you a much easier, faster, higher quality resource than most other options. And in this chart, you can see the difference between the ability of marking, say, with pad printing versus the quality, output, durability, flexibility of laser marking. It is the ideal marking solution for many, many types of applications. Common applications for marking with a fiber laser include barcode and serialization, data plates, industrial tags, medical devices, promotional items, tools, as well as electronics, smartphones, tablets, and laptops. Tools are an extremely common application for fiber marking, as the laser actually produces depth into the actual tool itself, producing a high contrast, long lasting mark. Weapons are another very common application used with the fiber lasers, as it can mark directly into this metal, producing that same high contrast decorative as well as serialization mark with the contrast and legibility to meet certain standards in certain industries. Aerospace is an extremely popular application for fiber marking because parts will meet the military and specs standards in order to put the barcodes, logos, serialization onto the components, individual parts built into an aircraft. Automotive, same thing as aerospace. Most parts are marked for serialization, traceability, for decorative, for instrument panels. There are so many different possible solutions that a fiber laser can mark onto the materials, producing a permanent mark into this industry. Medical is also extremely popular due to the fact that the fiber lasers produce that annealed mark. So bacteria can't grow when the material or metal is not actually subsurfaced. Inking processes typically are not legal in this situation for the fact that any one of those type of components can come off over time. An annealed process is a perfect solution for the medical industry. Electronics are extremely popular, whether it be decorative to the keys on your keyboard, switch panels, decorative capabilities onto like AirPods or Apple components, all of which, whether it be a component for visual appeal or for serialization and for logos, just the ability to keep track of that component, part numbers, etc. Personalization has always been popular. This is because you can actually mark onto the surface of the material and make it custom. So the fiber lasers are ideal in that case, from etching onto cutlery, jewelry, rings, electronics, whatever kind of component that will work on this laser system is typically an ideal mark, and it will increase the value of that object. The perceived value of something with a very, very high end fiber mark on it versus one that's not is considerably higher with that fiber mark. Asset tracking. Asset tracking is popular because stickers and other devices can be scraped or removed. The laser can produce that permanent mark that cannot be removed without damaging or distorting or destroying the product itself, because the mark is either subsurfaced and graved into the metal or discolored into the surface of the plastic, producing a contrast security based mark that cannot be removed, so that asset can be tracked at any time, whether wind or UV damage or staining or acid. Typically, a laser mark is permanent and there when it's needed. Things to consider when choosing a laser marking method. Things to consider, basically, the method that you need to mark based on the customer or the industry requirements. The material that you're going to process, the end use environment, how durable does it need to be? Desired effects such as bold contrast or color change. This is the questions that you'll need to ask, and we have professionals that will help you through this process should you need these questions answered. There are a lot of different customer and some industry requirements as well, such as FDA requires that medical devices and instrument meeting certain criteria must be annealed. Some OEMs require the marking for asset tracking. Governments has specific requirements for marking as well, such as UID. If you'd like to scan this QR code to learn more about UID on the Department of Defense for applications, for example, scan this QR code for more information. All laser systems, when processing or running materials, need to be exhausted. So, if you decide to move forward with a laser system, an exhaust system is necessary when processing materials. An exhaust system removes the dust and gas that's created during the laser when it's processing. It can either be blown outside or filter systems can be used and ventilate and filter the materials that are being outgassed from the surface of the engraving process, ensuring a safe and clean operation for your laser equipment and operators. The correct exhaust system configuration is imperative for your safety of operators with a laser system. Trotec offers many different marking systems and accessory options. We have so many different models of both fiber and CO2 lasers, galvo and flatbed solutions, ranging from standard fiber lasers to MOPA lasers, low wattage CO2s to very high wattage CO2 lasers, rotary options, and many, many different choices, as you can see here, as just a small sampling of what we can provide. If you would like to know more, please contact us and we can help find the best solution for you. Here are some other resources. If you'd like more information on UID marking and understanding for government qualifications, please scan the left QR code shown here. For UDI marks for medical engraving and stuff like that, please scan the center QR code here. If you would like information on a metal tag supplier for marking on with a fiber laser, you can scan the QR code on the right here for a metal tag supplier. If you would like information on sources for barcode reading and or verification, here are 3 different companies that we have worked with that produce quality equipment used for scanning as well as barcode verification: Cognance, Keyence, and Microscan. Trotec is a global company with 70 locations worldwide, all staffed by Trotec employees. We have offices located throughout the country, which offer direct support from the manufacturer at a local level. We provide user-friendly, customizable software and configurable workstations that meet all your needs for laser processing and marking. If you'd like to know more information, you can please contact us or check our website at troteclaser.com. And if you'd like to ask me any question, again, my name is David Stevens. My email address is david.stevens@troteclaser.com. I thank you so much for spending the time with me today and learning more about marking with the laser processing solutions.
Okay, David, thanks so much for that great presentation. Okay, David, here's your first question. Can the systems be integrated into existing systems and processes?
Most galvo laser systems can be integrated into existing processes such as a production line and assembly line. Control of the marking process, including the data to be used, is possible.
Okay, David, thanks for that answer. Here's another question. Are there any additional safety requirements or special precautions?
The fiber laser wavelength of 1064 nanometers requires a light, tight enclosure during the marking cycle, or use of the laser within a controlled area with proper precautions such as safety eyewear.
And once again, thank you, David, for that answer. Your next attendee asks, are the systems configurable?
Laser systems have many possibilities for configuration, including standalone workstations, inline processes, and integrated solutions.
Okay, thank you for that. Here's another question. Can you change the colors of the marks?
There are additives available to enhance color or contrast of a laser marking on plastics. For metal, it is possible to mark a range of colors on stainless steel and titanium. MOPA laser technology improves this process of metal color marking through the control upholsteration of the laser, thus controlling the level of heat transfer.
Okay, let's take a look at another question. What type of pre or post processing is there?
Depending on the end use of a product, pre and post processes need to be considered. Some materials have pre processing, such as hardening, testing, and cleaning methods. Post processing, including cleaning of an area, surface coatings, salt spray, and other environmental testing and structural testing. The end use environment of the material also needs to be considered for potential effects from weather, heat, etc.
Okay, thanks for that answer, David. Here's another question. Which marks meet mil-spec requirements?
2D codes and ECC 200 codes will meet these requirements.
Okay, great. And along those same lines, how long do the marks last?
Laser marking is considered permanent due to the change to the material surface or subsurface. Most laser markings are permanent unless intentionally removed or covered.
And thank you for that answer. We've got a lot of questions that came in. Let's take a look at another one. What happens to the chemical makeup of the metal when it's marked?
Depending on the type of marking, the metal is vaporized, ablating that metal, or a carbon layer is created, creating an annealing effect.
Okay, and the next attendee asks, what is the cost of ownership?
The cost of ownership is minimal, very low power usage, no consumables, and also extremely low maintenance.
Okay, great. Here's another question, David. What is the typical ROI on a standard system?
This varies depending on the number of factors and influences.
Okay, David, thanks for that answer. We've got time for a few more questions. Let's take a look at the next one. Can PVC be engraved?
No, we do not recommend processing PVC materials. PVC produces a harmful and corrosive chlorine gas when it is laser processed. So we do not recommend laser marking any PVC products or materials.
Okay, and another question that came in. How deep can a fiber laser engrave in cast iron?
The depth of a laser marking is dependent on the level of power used and the amount of time or passes the laser is allowed to remove that material. Deep marking can be optimized and maximized through proper settings and movement of the focal distance to maintain a focused laser during this ablation process. The deeper the laser mark is, the less controllable and quality of the marking.
Okay, David, thanks for those answers. And with that, we're going to wrap things up right there. David Stevens, Industrial Applications Manager with Trotec Laser, thanks so much for taking the time to be here with all of us today. And we'd certainly like to say a special thank you to all of our audience members for being part of this webinar event. Take care and have yourselves a great day.